Welcome back, students. So let us start further. So in the previous video we see some of the properties of the polynomial function. Let's move forward and see some specific questions. So here we have some questions related to the domain and range, and I'm sure you know how to do them. And second is the end behavior. Again, we have done it, and there is also one more term that is called identify any symmetry. So let us talk about that term also. So how do we figure out if there is any symmetry or not? So not all the polynomial functions are symmetrical. Okay, so symmetry of polynomial functions. So we have two kind of symmetry that are possible. One is called line symmetry, and it is possible when, number one, the function is even degree, and second condition is the function is even. Now you can see, student, there are two terms that we are going to use here. Function is even degree and function is odd. And let's go further first. So second type of symmetry is, we call it point symmetry. So point symmetry condition is function has odd degree, and second is function is odd function. Now obviously you know the meaning of even degree and odd degree, what they actually means. What are these functions, even and odd function? So let us talk about that. Even function. Okay, so we call a function even when f of negative x is same as that of f of x. Okay, and what it actually means, that when I replace x with minus x, this negative x, in the original function, I should get the same function back. Okay, then if that is the case, we call it as an even function. So let us take an example. Say we have an original function fx is equal to 2x raised to power 4 plus 3x raised to power 2 plus 5. Now when I do f of negative x, it means 2 times negative x raised to power 4 plus 3 into negative x raised to power 2 plus 5. And when you do this, you get 2x4 plus 3x square and plus 5. Now you can see both the functions are same. That means this function is even function, and obviously its degree is also even. Okay, similarly, if you take another example, like say fx equal to 3x cubed plus 2x. Now when you replace f with negative x, you are going to get 3 into negative x raised to power 3 plus 2 into negative x. So when you do this whole math, you will get negative 3x cubed minus 2x, and when you go further, you can take negative out. It should be 3x cubed plus 2x, and if you look into that's your original function, so you can just write it means it is equal to negative f of x. So if that is the case, then we call this function as odd function. Now how you can quickly identify if the function is even or odd? You don't have to do these calculations. You can just look into the function, you can figure out. And the rule for that is, if all individual terms of any function have degree even, then it's an even function. So like you can see here, the degree is 4, which is even, the degree is 2. Here you don't see degree, that means degree is 0. And also we put 0 in the category of even number here. Okay, so all these terms are even, that means your function is even. If you look into the second function that I have taken, here this degree is odd, and this degree is also odd because that's 1 and that's 3, that means the function is odd. If somewhere you see the mixture, then that means it's neither even function nor odd. And how you can prove that? So I'm taking an example. Say we are going to take fx equal to 3x square plus 2x plus 5. Now what we'll try to do, the method that we use, just replace x with negative x and see what happens. So 3 negative x square plus 2 times negative x plus 5. And go with the math here. So you see 3x square negative 2x plus 5. So first of all, we have to see if fx equal to negative fx, f of negative x, this is not true because this term is positive, but this is negative here, this is positive and this is negative here. So they are not same and the last terms are also same. So it does not meet that requirement. Now they're saying if you take negative out from this function, the final that you got here, this one, do you get the original function back? So I'm factoring negative out and I should get negative 3x square plus 2x negative 5. Remember, when you factor out negative from any function or any expression, all the signs of inner terms will change. So now again, if you see it, it's not fx. So that means this function does not fall in the category of either. Neither it is even nor it is odd. And the reason for that is because here the degrees are mixed. So you can see first degree is even, second degree is odd, and third is again a kind of even. So that's the things that we can check. So if the function is even function, that means it will have a line symmetry, and if it is odd, then it will have a point symmetry. And again, I will tell you what it actually means. So I'm taking an example. Say my one function is y equal to x square. You know that this is even degree and it's even function. So graph will look like this. And I then take another function y equal to x cubed. So if you draw this function will look like this. So, and it will go like this. So if you see this graph here, it will have a line symmetry. That means if I see this, draw this line, your graph is equally divided in both sides. But for this graph, you have a point symmetry. That means if I consider this point, half of the graph is toward this side, second half is toward this side. So that's called point symmetry. Okay, and this is the way you can figure out whether it has a line symmetry or point symmetry. So go through this. And there's some example already done for you. Now again, you can figure out whether this is a polynomial function or not. So you can look into the properties. Like I can just see here, this function is not polynomial because it does not represent a x raised to power n or something. This is not polynomial because here degree is odd, and this is cos. So again, this is not a polynomial function. Okay, for polynomial function, it is a n x raised to power n plus a n minus 1 x raised to power n minus 1 and plus so on. That kind of expression is required. Okay, so go through this. So we'll try to look into the main part of this unit. And again, the graphs are given to you. You have to identify what kind of functions are they. So look into this. Then we have a characteristic of polynomial functions. And this is one we were talking about, polynomial function of odd degree. Okay, so you can look into that. Okay, and now if we have some polynomial of degree odd, okay, and we have the function with say even degree function, then depending upon the behavior, you can see we have these terms: local minimum, local maximum. Okay, so local minimum means the minimum value in a certain interval. Local maximum means the maximum value in certain interval. And then we also have a term absolute minimum or absolute maximum. Absolute minimum means the minimum value a polynomial function can have, and absolute value means the absolute maximum means the maximum value it can attain. Okay, so again, I will show you with the help of example what it actually means. So if you look into the graph, I'm just making a graph for you. So say, I think I'm drawing it wrong. Let me don't do that way. So let us draw it proper. So this is our graph. Now if you look into this graph, it says that it will keep on going this side, both side down. So that means it does not have any absolute maximum, means it does not have a highest value somewhere, or it does not have any minimum value somewhere, but it has some local maximum and local minimum. So if I look into interval from here to here, I can see it has some maximum value. Similarly, if I see interval from here to here, I know it has some minimum value. But we don't have any absolute, means there is no such value where we say that this function can never have any value greater than that, or it cannot have any value less than that. Now let me take another example. Say we have a function like this. I'm just taking a very simple example. This is, this is your kind of y equal to ax square. Now this is a parabola. So this parabola will always have absolute maximum. This is called absolute. Why? Because this function can never have value greater than this. Similarly, if you flip it, you will say that it will have some minimum value. So that's called your absolute minimum. So depending upon the interval, we can figure out the absolute minimum, absolute maximum values, and then we should know the type of function we are dealing with. Okay, so we'll try those questions. And then we have another thing. What is the relationship between the finite difference and the equation of polynomial function? So finite difference, students, you already know. Finite difference means whenever you have these y values, like say there is a first difference, second difference, and keep on doing. So basically what it actually means that keep on dividing, like y2 minus y1, then we do y3 minus y2, and then y4 minus y3. We keep on doing this way, like say this subtract this subtract this, and keep on writing those values here. So we get the first difference, we get the second difference, we get the third difference. Now why these differences are important? So if the first difference is same, that means the function is linear. So it will have a kind of ax, that is its general equation. If the second difference is same, that means its degree is 2. So it can be like y equal to ax square plus bx, something like this, plus c, means its degree will be 2. If the third difference is same, again, so degree and difference, they are related. The difference, which difference, finite difference will be same, that depends upon what is the degree of the polynomial. For example, you see this, okay, you will get to know that its third difference will be identical. Okay, and then we have a formula that we use many times, that is the relationship between degree, finite difference, and leading coefficient. So difference is always equal to leading coefficient times degree factorial. Okay, so if they give you two terms, you can find the third thing. Okay, for example, say they give you the difference value is say 24, and they say the degree is 3. Then what do? You can find the value of a. So you can say a times 3 factorial, and it should be 24, and a times 3 factorial, this means 3 times 2 times 1. That is the meaning of factorial. Factorial means n factorial is equal to n times n minus 1 times n minus 2, and you keep on doing till up to 1. So if you do this whole math, you will get 24 equal to 6a, and divide both sides by 6, you will get a equal to 4. So you know that its leading coefficient will be 4. And similarly, if they give you leading coefficient and they give you degree, you can figure out the finite difference. Okay, so this is how we find the finite difference values. You can review this, and then they're asking you, like say you have to match some polynomial, they have given you degrees. So let's try to match number 2. Okay, so if you look into this number 2, you can see here 1, 2, 3, 4. So there are 4 x-intercepts. Remember, students, if the degree of the polynomial, the maximum degree of the polynomial will be equal to the number of leading coefficient we have. Okay, so your leading coefficient, not leading coefficient, but x-intercepts. So in this case, I see the x-intercepts are 4. That means my degree need to be at least 4. So let us look into where I see degree as 4. So I can see here degree is 4, but that does not match with it. I see degree here 6. Again, it does not seem like matching, but we can check it. And there is another thing you can see, students, here. It's going from quadrant 2 to quadrant 1. That means leading coefficient need to be positive. So leading coefficient need to be positive, and x-intercept I see 4. Okay, there may be 0 x-intercepts. Okay, so we need to figure out. So if I look into all these, here the degree is odd, so that means, and leading coefficient is positive, so the graph possibly could be this. This is the graph for A. Okay, similarly if you look for B, they are saying leading coefficient is negative, degree is even. So if I look into that graph is here, so I will say this is B and behavior. Okay, and then you look into C, degree is odd, leading coefficient is positive, that means it will go from quadrant 2 to quadrant 1. So that's your answer here. So this answer is C, and then I think this is the answer for D. So this way you can look into the graph and you can figure out the values. And this is about all finding finite differences, and then we have to figure out the value of leading coefficient and all kind of stuffs. You can try these questions. And I think this is all we have for this unit. So we will start with the next soon.